Okay, welcome everybody. Hope you're having a good day wherever, whenever you may be. Hopefully, my sound's a little bit better. I'm going to be trying adjust it a little bit. The sound was really off the last few days, so hopefully this is better for you. Um, I didn't really do any reviewing of day. I make any changes to day 5. Um, yeah, I felt like it was good. I did some more reading of people, and there's a lot of people saying like, "Oh, but it's this or that," and I think people are just probably, in my opinion, overanalyzing the day, which, to be honest, is not necessarily a bad thing. I know people really get into this stuff, and that's okay if you're into it, right? So, um, cargo new day 6. So let's just start started with day 6 and see how it goes. Dun, dun, dun. We'll zoom in a little bit. We can close day 5. And here we go. Guard Gallivant. The historians use their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab in the year 1518. Okay, we're actually going back now. What is this a link to? It turns out that having direct access to the history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid anyone in 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You start by making a map of the situation. For example, blah. Okay, is this the guard? Okay, so we're going to do some movement game. The map shows the current position of the guard with this to indicate that the guard is currently facing up from the perspective of the map. Any obstructions, crates, desks, etc. are shown with hash maps. Lab guards in 1518 following a very strict protocol. If there's something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Okay, so are we going to just be following the guard? Yeah, okay, so we can mark with an X all the places the guard has been. The guard will visit 41 distinct positions on your map. How many distinct positions will the guard visit? Okay, how big is this map? It's not the biggest map they've given us, but it's pretty big. So I think we want to definitely start with the test. This one. We'll pop it over here just so we can look at it if we need it. But this is, I mean, this is a great, I guess I don't. Where is he? Oh, okay, right here. So it is up. So I think we can just parse this and do our graph stuff, and we'll have the guard's position, and we'll just move him in the graph until he hits something. Move him until he hits something. Da da da. So he'll move around a bunch of times until he goes out of bounds. Is how we'll be tracking it. Okay, so let's create a couple data structures. Sure. An eye size. We don't need a distance, but we will need a new. We'll just add itertools immediately because we know we'll need to have a neighbors function. So we will need a graph. We'll call it a map because that's what they call it. And we just need nope, it's not a hash set, it's a hash map of point car. So the idea behind this is we'll have a map with all of the different points on here, and we'll be able to track. What was that from VS Code? We'll be able to track where we are using something. I mean, maybe we'll just do it in the main program. But and then we'll have this little where his current position is as well. That we'll need to track. So we should probably actually do that as well. So if we impl map, we're going to have a fn new where we give input string, and we're going to give out we're going to return a point, which is the current position that it finds. And we can do, I don't know what the AI is trying to do here, but we'll do let mute current position equal point, just some empty point. And then we can probably just iterate over the string. But because we are using eye sizes, we want to use a zip again like we did last time. So we'll do something along the lines of let positions equal input dot lines dot zip 0 eye size dot flat map line y line car zip 0 eye size map cx point is equal to new. It's going to, so this is going to be this. So we say if the current character is this, then the current position is this position. Otherwise, we just put the position down here. Oh, we should also change C equals dot. It's not going to like that, right? Oh, is it really not mad? Oh, it's not mad yet. I need to do some impls up here first. Expected point found map. Ooh, I actually need to return both here, huh? Yeah, so you can see it doesn't like this. . I think we can just go up here and change this to mute, like that. Value assigned to current position is never read. I actually don't know what this is saying. What is this doing? There's no way that fixes it, right? Yeah. No thanks, AI. Like, what I want to do is set the current position. Value assigned to current position is never read. Maybe is overwritten. What input equal? Ooh, did I put these in the wrong place? No. What is it trying to say here? Okay, but that one doesn't. I mean, I realize these ones were unused, but why does it think this one's unused? Can I not just do this inside a functional way? Like, obviously, I could do this in 2 for loops, and it would fix it. Excuse me. So it does feel like something's out of the way. I'm under the weather right now. I mean, is this actually the case? Like, if I... It doesn't update this. But, like, the question is like, how does that even work if it doesn't? Yeah, like, it never finds it, even though it's clearly... I mean, it's obviously there. Where was it in the test? So 1, 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. So it's actually 4, 6. I'm looking for 0.46. I'm probably never going to find it in here. A dot? Oh, why does it give me a... Oh, it gives me a sum because I'm just asking it what it is. So, I mean, it does, this part is definitely happening. Okay, how about we do Rust update closure variable within a map. Oh, dang it. Yeah, it wants me to move. Whoa. So I can do a move. Here's what I could try is I could try and do like this. Let C equals if C equals else. C? It still doesn't like this. Probably still works if I do it like that. No, it still doesn't like it. Closure may outlive the function, but it borrows Y, which is owned. Where does it borrow Y? Did I do something weird up here with my point? People say you have to fight the compiler, and you do, but it's for a good reason, right? It's trying to help us. Point new. Y is borrowed here. I've totally done this before. Right? In day 5. What am I doing different? I'm probably missing something. Obvious. Can I blame it on my cold? was it day 4? Oh, it does have a move here. I do move. Okay. That's going to move this. So the question is like, do I just iterate over it? Like the problem is now if I do something down here, it's going to move this out and I'm going to go back to my original error. So what do I do? What do I do? What do I do? I mean, if I probably just do it in a for loop. But I don't want to enumerate. I want to zip. And these are going to be switched when I zip. And then we'll figure it out for that. If C equals that, C equals that. And then, oh, I need a hash map up here. Okay, there, now it's happy with that. So I should be able to 4-6 it. Well, I feel like it's kind of funny. I spend half my time figuring it out in Rust. I presume I'm just really rusty with Rust. See what I did there? Okay, but now we have the map. So we should probably have a function now that like this, but and then we can in the point we can okay, so we can create a enum for a direction, and we'll say we'll do an fn move. Yeah, this is good. So if I'm north, I'm gonna go -1 +1. Da, 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 da. I don't actually move myself. So maybe I just call it I don't know where. Nope. Next is probably poorly named. But that like tells me where my next point would be based on a given direction. And so down here in part 1, I can say can I not make them both mute? Oh, it just says they're unused. Okay, I think I can do that. So we're always going to start going north. And then let mute scene equal hash set new. And then we'll do sorry, I'm getting texties from my wifeys. Let mute scene equal hash set new. That's going to be where we're going to track the ones we've seen, the ones we visited. And so obviously we'll start with scene dot insert current position. You'll value current position? I don't know. And then we'll say while let some C map get current position. Yeah. I mean, this is the start of it. This, I have no idea what this is. So, but we want to do this while let some C map get current position. So basically what happens with this get is we return an option and a character. So if the point is not in the map, it will return none here. Otherwise, it will return some. So we can do a while let some where we get that position. So if there is none, then we're done. And then for P1, it's just how many we've seen in that thing. So now just we have to do this inner part where we say actually I can do this scene insert here. And then what we want to do is try to move our current direction if we can't. Ooh, this while loop may not turn right. Is that what the instructions said? Turn right. So we can do a nope, that's not it. Impl direction, and we can do it's not turn left. We're only gonna ever turn right. Make this a pointer or a reference. I don't use I keep saying pointer, but I realize it's not. Like we actually don't even use C here. This is what I was thinking about earlier, is we maybe just do the whole thing in this loop. We actually probably do this in a match. So if it's sum and a hash, we actually direction dot turn right. Oh, I spelled that wrong. None. We break. That means we're done. Otherwise, direction, or let's see, current position. equals next position. What doesn't like about this? Expected comma. Oh, I need to wrap this all in a. Nope, not that. Oh, can I just? Because I don't actually want either of them. I'm not interested in returning anything. There's probably a nicer way to do this. But so here's the thought process. Wherever we are in the loop, we just insert our current position. It will duplicate as we're turning, but the idea is we figure out what our next position is based on our current position and the direction we're going. And we go and get that next position, right? So if we're facing up, we look at what's up above us. And if it happens to be a hash, we know we've run into something, so we should turn right. If there's nothing there, we know we've gone off the map, and so we should break. We're done with the whole solution. Otherwise, it's a dot, and so we can just keep going, right? And then we move. So the idea is you'll do these dots until you keep going, and we hit this one right here. Oops, why does it keep doing that? So we hit this one right here, right? So we're at this position, and we notice, oh, we're going to get stuck. So now we turn right, and so now we're facing this way. And so we'll loop again, and obviously we'll do the scene insert again. I guess I could optimize that by just moving the scene insert right here. Okay. So now, and then we'll move this way, and then we'll get caught here, and we'll change our direction. So the only thing I didn't look very closely, if we're going north, y is -1, south, y is +1, east, x is +1, y is x is -1. Okay, that's okay. So this feels like it should work-ish. And it goes on forever. It should definitely not be this long. So I've got some loop. Hold on, sorry, I'm going to pause the recording. I will be back in 1 second. I just got to do one. Sorry, I'm back. This cold is killing me. Okay, let's see. Why would this go on forever? I mean, we can just, let's... see what it starts spitting down. So 4, 1. 0, 1, 2, 3, 4, 1. Oh. Okay, that would explain the warning too, that it wasn't set to mute. Okay, let's get rid of this. See, the compiler does help you. You just have to pay attention to it. 41. Is that the right answer for the test? It is. So let's try it on the input. That's the right answer. Okay, so let's just like recap what we saw here. What's going on? We know we're moving in the grid, and I mean I'm thinking through this. There's no more efficient way to do this than just traversing. Right? So you just take this little guy and you literally robot him all around the room. And then what's the easiest way to do this? Kind of in a loop. Like the optimizations here are probably like what's happening in these places. Oh, I bet I can get rid of these now. That's what was happening here. I didn't have this direction equals thing, and so it was treating it as a direction, like I was returning a direction, and this one is not. I mean, it'd be nice to figure out how to do this in a functional style way, but I mean, this works okay. So the idea is we have a bunch of points that are going to be used as like the key for all these. Where is everything in this grid? And that's what this new function does. Is it takes all of them and it zips them with the zeros. Again, I'm using zip because I want an I size as opposed to enumerate. If I was just looking for a U size, I could enumerate. But because I want to like look up and down in the negative directions, right? Because sometimes the north will put me into like a -1 space or whatever. Oh, that's interesting to think about. Like you could potentially um just start this at like 1 1 instead of 0 0, and then you'd go out of bounds at 0 0, and then you could actually use I sizes. I hadn't really thought of that. That's an interesting idea. Maybe I can do that. Anyway, I don't think there's anything particularly interesting about part 1, right? It's just, can you follow directions and can you debug your code? Which it took me a little while to do, right? How long have I been doing this? It doesn't say on my thing. 40 minutes. Okay. Let's go to part 2. While the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you travel through the last few months and record the nightly status of the lab's guard posts on the walls of the closet. Returning after what seems like only a few seconds to the historians, they explain that the guards' patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in a way such that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is right where the guard is right now and would notice. In the above example, there are only 6 different positions where the new obstruction would cause the guard to get stuck in a loop. The diagram of these situations uses 0 to mark the new obstruction, and pipes to show where the guards moves up, down, dashes for left, right, and plus where they move in both directions. Option 1, you put it right where they started, and then they kind of go like this. Okay. Put a stack of failed suit prototypes at the bottom right. Oh, right here. Okay, so normally he would go down here, but you put him right here, which triggers him to go this way, and then this way, then this way, then this way. So this is the loop you're creating. Option 3, you put it right here to create what loop? Oh, this loop right here. Okay, if you do it right here, what does it do? When is this one happening? Or where is the box in this one? Okay, so he starts here, goes up, then here, 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 here. Okay, so it's this rectangle right here. Okay. So what is the brute force approach to this solution? To start placing obstacles in random places. I mean, not random. Anywhere there's a dot that's not the beginning point. And seeing if that causes a loop. Now you have to say, how does the loop? How does the loop occur? It feels like there might be an easier way of like, can you find these three positions, right? And so how would that look? How many X's are there in, or how many hashes are there in here? Is there an easy way for me to do that in VS Code? If I search for hashes, does it tell me how many there are? $771. So like what's going through my mind is, right, if you can I even find one? Yes, I can. Right here. So if I look at this one, and sorry, this is going to be hard to see. If I'm going up in this direction, then I hit this, and I go this way, and I hit this one. And so if I place one right here, sorry, right here, or right here, he'll go down here and hit this. Oh no, that one doesn't work. No, I place it right here. So he'll hit here and go down here and hit that, and now he'll turn this way and go here, right? And now he goes dun dun dun. The effect is, the idea is, if you're looking at this graph, can you see so this along this x-axis, along the x line next to it, can you find another hash? And if you can you look down below it and find another hash? And if you can find those three, then you know you can place it the one like minus this one and plus this one. So like right right there where where this flashing thing is, because it'll come down here and go here. So you need to know, the hard part about that is you need to know what direction he's going, right? Maybe he never actually hits this one. So you have to go through the board and place all the positions that he's going. Can we do that with the test text? Test text. If we make this map mutable too, and we say, what is the... I mean, it's right up here. Why? Oh, it's not the map. It's the map.positions.insert. Like that. Then after this, can we just like print the map and see what it looks like? I actually want to print it like this. I need to, I really want to print it, so I'm going to do like a let max x equal max p of x, max y equals that, and then we can do for y in 0 to max x equals print line. Like that. Ooh, but it doesn't show the crosses. Like he's gone two different directions at that point. Okay, so we could track all the directions that they were going at that position. So if we say let mute directions equal hash map new, and then for each of these we do we insert that, and now we should have all of them. So let's see if we'll just put a plus in there. Otherwise, we'll put whatever was in there. Oh, let's see. We'll do if direction, if let some c directions.get p. It would be let some, I don't know, dd, if dd.lane equals 1. This one's going to be a plus. So if we only have one direction, we're going to map dd0. What am I saying? What was I saving in the directions? Oh, I am already doing the chars. So I just print dd0. Nope. Why does it think it's a car? Oh, because I'm only treating it as one. I need to do entry current position or default dot push that. Type mount speed. Oh, okay. I just need to tell it what this is. It is a hash map of a point and a vector of characters. So what I was doing is just entering one value and then replacing it, but I want an actual vector of them. So I'm going to say, this is where you do this crazy thing where you say, hey, get me the entry for current positions. And if there's not one, create a default one for it. So I'm going to get back a vector here, either a new one or one that's already existing. And I'm just going to add one of these to the end of it. Yeah, there. Now you can see the pluses. Yeah, map is not mute anymore. What else are we mad about? Nothing? No? Okay, so you can see the direction they're going. So the question is can we infer do I just part of me thinks the brute force may actually be okay. Like you can imagine for each place that I am, if I just place a block in front of me and then ask it to like now test the thing, and the way that I know I've created a loop is if I'm back in the same state, meaning I'm going. So like if I were to put, let's see if I can look at one of their solutions. Maybe before they have a solution. So we know that if we put a block right here, it does it. And the time that I would test it is if I'm right here and I'm going this direction, this way. Because normally without this here, you go here, here, down here, and then you'd be right here and you'd be going this direction to the west. And so I would say, well, what if I put a block here? Does that take me back up? And if it does, my goal is to keep running until I see this position again, where I'm going this way and I hit this wall. Um, I don't know. It might be easier just to say, like, the struggle I'm having is the algorithm that seems good to me, and maybe I just haven't thought this through enough, is to look for this triangle right here throughout the grid. So you start here and you look for this one that hits just below it, and then you look for this one that hits below it, and then you can, if you do these three and they hit, you now know that this position right here will cause it to go back to this, right? You can kind of like, I mean, you don't know because there could be something right here, right? So you'd still have to follow it through. Like, suppose there's a block right here. You might say, oh, I found this one, and this one. And so I know I need to go here. I mean, you would just check, is this clear? Can I, from this position, can I get from here to here? And if so. And so there's 5,000 of them. There's, what did I say? There's like 55. How many X's were there? Or hashes? 771. Okay, there's not a lot of them. So there's 771 of these, and I just need to check above, below, and on each side to see, can I create one of these hashes or one of these squares? And if I can, add it to a list of known blockers. Like, this is a known one. I can place it right here and create a block and add that to my list. It's going to be a lot of copy and paste that I can probably clean up. This is why the brute force is sometimes more fun. It's easier just to get it done. Okay, but in part one, at least I now know which directions I can be at any point. And so I know if I'm doing that, if I'm in the right place. So I can do something like, let's just write, we'll have a let found equal hash set new. Let's just start trying to write it, is what I'm saying. So if we do like a find loop, and we want to have the map, the directions, the initial position, we'll have the initial position, and whether or not it was found. Oh, do we even care about the initial position? We don't. But we do care about each of the points. So we'll say like it'll be like for so for each of the ones we found a hash, we want to run this find loop function. So values. Oh, it's map dot. Like that. Okay. So we're basically going to loop through all the points that have a hash. And we're going to call this find loop function, right? So func. Nope. Fn find loop map direction. Oh, I'm missing the point. One day I'll get used to. Wow, why does it think day 4? Oh, I mean, I don't know. Sorry, I missed the mute button. So it'll be map pointer to map. I mean, I have no idea if this is correct, but I'm sure this directions map vec car found hash set point and a start point. So like, what does this do? Let's just type that out for a second. So we want to check the north and south horizontals. How do we actually do this? We want to check for surrounding points that are moving in the same direction, or that are moving into our starting point, right? Like the algorithm is, if we're testing this one, we want to look around and say, hey, are there any around here that are actually pushing into me? And if there are, then I know that this is potentially one of the loops. And so I should follow it along its horizontal. Okay, so let's see. We want to check for the surrounding points that are moving into our starting position. We can then see if the turn hits an obstacle, if it hits an obstacle, does that obstacle cause the movement to run into a line that would cause the movement to loop back to the starting position? Like, that's essentially what we're asking. But it just occurred to me, could you have like a big box and a small box and make a loop? Like, here's the trick sometimes in Advent to Code. The reason why I'm wanting to follow this like square pattern or rectangle pattern is because all the times that it makes a loop, right? So like this loop right here, the bigger loop right here, you'll notice all the times that it like makes this loop. So this loop, what is this one doing? Oh, it's right here. This one right here. And ding, 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 ding. This loop right here. You can see they're all squares, or rectangles, I should say. They're all rectangles. This one's a rectangle. So is that like the trick to it? Wait, is this one? What is this one? Ooh. No, it's not. This one is not a rectangle. Right? So this one goes up, down, da, 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 da. Yeah, the rectangular pattern doesn't work. So I had missed this one. Sometimes what I was trying to say is sometimes you can see a pattern in the test thing, and while it is not a generalized solution to the algorithm, right? Like you can say this, it doesn't work in the general case. It does work for the test cases or the case of your like input. And like that's something you can infer to like help solve the problem easier, right? Like my thinking is this would be easier. This little test right here would be easier than trying to come up with something more complicated, or I should say it would be faster. So do you have to brute force it? And by brute force, I mean like, I kind of want to do this with the input, not this part. Oh, I got rid of that print stuff, huh? I kind of want to print out the input so I can play with it after I have all the scenes and positions. Maybe I can do it with the test case. Like what you end up with is you have this map of X's. These are actually all the places you want to test hitting a block, right? I mean, it doesn't show them all here. but you know it hits these places, and so you want to say, well, what if I put a block here, does that cause a loop? And like what would cause the loop is if I ever came back to this block in this position. But like how do I know? And are there infinite loops? I mean, I feel like maybe that's just what you have to try. Okay. So it's actually the directions you want to do. So for each direction that I'm going, wish I could spell. I'm going to keep blaming this on my illness. Okay, we're just going to put this in here like this. What doesn't it like about that? Oh, I told it was a car. Okay, so how does this change? Um, assume we put an obstacle on the map at the position that would the position the next position of the direction we are going. We should then follow the path until we get back to the same direction and point, or go off the map. Right? I mean, this feels kind of like the brute force approach. I'm. What do you say about brute force? What is brute force? Potentially, you could say I'm going to put a 0 here and then run it and see if I ever encounter, if I ever get to the same position and place again, which is essentially what I'm doing, except I've limited myself to the scope of like how many there are. Um, like this is not going to work, but I do want to. How many directions are there? It's going to be directions dot values dot map v lane sum u size. Oh, this is just on the test. That does seem right. Okay. I mean, that is a somewhat non-trivial amount of overlap. But again, it's only 6,000. So we're saying we're only going to test it 6,000 times. What would be a... I keep thinking like what's going through the back of my mind as I'm trying to do this is there something I'm missing? But who knows? I'm just going to try it this way. And maybe we should we'll probably, if it starts feeling like it's going to take long, maybe we just do the thing. We'll like keep track of how many times we've done it so we have an idea. So I kind of want to do this right here in a function. Sorry, hold on a second. Sorry, when you hear your kids screaming, you tend to worry that something might be wrong. But they're just playing video games and very excited. Yeah, I don't think I need that anymore. Oops, what did I do? I'm not getting into VS Code very well, am I? For some reason, I keep closing it. Okay, so I think we just follow this through. Oh, I wanted to like update the map, right? Like, is there? Can I put a function on the map to basically like do this work? Uh, like, is it worth it? Probably not. We can try and fix it later. But the idea is we'll say like let mute map equals map.clone, and we'll say map dot if map dot get we only want to do it if it's a dot, right? So we say if we get the next one and it's a dot, then we insert at our next direction, else we return. Yeah, this time it got it right? So the idea is we're going to take our map, clone it, make it mutable because we need to modify it. And then we can do some optimizations to that later if we want to. But basically we say, hey, go see if my next movement is a dot. And if it's not, right, if I'm hitting something already, there's no sense in me testing it. Or if I'm going off the map, there's also no sense in me testing it. So we return in those cases. Otherwise, we insert it. So now we put an obstacle. We've put an obstacle at the next position. Now we're going to just run this loop right here. And what is the loop? We're going to... Okay, so we'll say let mute current position equals start. We'll just clone that, and same with... let's see. We want to do current direction. Is it smart enough to... If I change this, is it only gonna... Nope, it changes it up here too. Although it's probably faster just to do that. So this is direction. This is direction. This is direction. This is direction. And now the rest of these are current directions. We don't need to do these. So if we find a block, we're going to turn. If we find none, we're going to break because we've gone off the map. If we find... If this is a valid one, we should then... So right here, we should say if... that found.insert start and break. Yep, like that. Like if we find the current position is our... If we're at the start again, where we began this whole thing, and our current direction is where we found it, then we do an insert and we start. And then, what are you mad about here? Oh, am I missing a line? Okay. Map doesn't implement clone. We can fix that. Bada bing. Okay. So what is the algorithm? Again, it's sort of brute force. It's not sort of, it is. It's not like the most generic version of brute force. We have done some pruning. Okay, but we basically say, let's update that with the direction and position we're going, with our current position and direction. Let's set the next one to be an obstacle. And then let's just run it through until we get to where we were before. And if we get to where we are before, then we know we've hit a loop and we can stop and leave. If not, if we go off, we know we haven't. Otherwise, we just keep moving, keep moving. Okay. I'm really scared to run this. It could be that, like, 6, is that the right answer? That came back pretty fast for the... Yeah. Okay. How long does the input take? My hope is under 30 seconds. It's spinning. Um, how do I open up like the task manager? Can I see like the CPU? I mean, it's not a lot because I'm only using one CPU. I can do um, what is it to run the dash R to run the release version? And that'll make it spin up faster. I could try and start using all of the CPU too. Um, there's a library called. Sorry. Let's see. What is that? Well, this is running. This is surely not the best way to do it, though. What is it called? It's not threads. Oh, is this it? It's called, yeah, Paritor. So what you do is up here. Okay, this is taking forever. So let's cargo run, or no, cargo add Paritor. And then up here, we can do. Like this. And then you literally just change this to. Oh, Rayon. Man, I'm using someone else's stuff. Cargo, add rayon. Oh, it doesn't like this because I have a mute found. So this, I'm going to change this to either return a. We'll have it return a bool. And then here it returns false. And let's see. Right here it returns false. And right here it returns true. So we don't actually have to have the found now. Yes, thank you, Future Highway. We want to filter. Is it just... I mean, that seems dumb. Can I just filter map on this? And then do a dot count. Like that feels like what's happening. Why is it not happy? Expected block. I'm probably missing. Sorry, I'm going to zoom out for a second. Okay, so for point directions in directions, iter. Oh, I have it in a for loop still. Like that. Like that. The var iter exists for struct flat map point vector direction, but its trait bounds were not satisfied. It's probably because I'm using this flat map, right? Let's just... Sometimes it's easier to like see it in the thing. Does not satisfy into parallel. I mean, we can just do it like this. Maybe I should Google Rust par flat map par iter. Ooh, does Rayon have? Par iter. Okay, so I can do it after the fact. Like this. It doesn't like that I'm doing it that way either. Like I want a flat map because I have I could have more than one direction. Do I just need to do a clone here instead of a move? That doesn't seem to help. Okay, let me try and understand why it's not happy. It's the filter map. Par iter. Okay, so par iter flat map into filter map. I mean, I can search the Rayon. Sorry, I'm used to. Why doesn't Control F work? There is a filter map. Is it because I'm returning a bool? Oh, that's right. Filter maps work on. So I just do this and then I return none. The trait bound standard iter map. Into parallel iter is not satisfied for the following other implement types. Is it that I just can't do them in order? So do I just do. I mean, let's just try it this way for now. We'll map it like this and we'll say. I don't want to change this right now because I may change it back. But we'll say if let some Oh, was I? I think I didn't turn it into an iter up here. Is that my problem? Nope. So let's just try this. So we're gonna do a par iter. The reason why I think it's not working is like, does this work on hash maps? It seems to think it does. I mean, let me just make sure. Rayon par iter hash map. I spelled that wrong. Oh, okay. So it does implement it for a hash map. So we say this is a lot of work for a solution that may not work out, and it's getting late. So this will be funny. Okay, so let's just try a straight up map. And we're going to change this to a sum of usize. And so this is going to be that. So it's not strictly, oh, and that does actually compile now. It's not strictly 100% parallel because any of them where there's multiple, it has to try twice in that way. Okay. Let's see what this does to my CPU. Hey, look. Zoom. I don't think it's getting us there any faster, though. Is there a way for me to break this out? Change graph to logical processors. There you can see all of them. Just wondering if I could hear it turn on. This is not faster, right? Is there something I'm missing here? So I have the new. I created a clone of the map. Yeah, I agree. I think I'm looping hard somewhere. So let's just walk through this for a second. Think about it. I create a new map. I insert in my next direction a hash. Ooh, are there places where I spin around? Yeah, like right here. Do I ever get in here? Like if I put one right here, I'll just spin around forever. So that's a potential problem. Is that the actual? Here's another one right here. So how do I fix that? I can do like something kind of cheesy here. I can say like if uh I can check all four directions and say if I've like bounded myself. Actually, that shouldn't loop. Should it? Okay, here's why it will loop. Um I'm only checking this right here, right? So like the what happens in the loop is I say, "Hey, is there a I find the next position and then I go get it and I say, "Hey, is there a hash there?" If there is, then I need to turn. So I really should be checking this after I do this. And then that checks both cases. Is that right? Let's just try that, see if that helps at all. This is still, I would really like it to finish faster than this. So I kind of almost want to test one, a single one, to see how long it takes and to see if it's looping. So let's save this and do let mute p2 equals 0 for point in directions. And then we'll print this out. I also want the count or the direction though. Do I want to go deeper than this? Because cycle detection incorrect. Okay, I'll check that out in a second. 6123 west, and it does. You can see it like freezes. It's not like I'm just checking a bunch of places. It is. Yeah, you are right. It's like some point I hit a loop. So it's when I'm testing 6023. Ooh, it actually finds some 6123 heading west. So let me map clone. So we have our new map. Try to move our current direction. If we can't, turn right. I mean, that part, so we're looking for our next position. So if we get that and it's blocked, we turn. If it's not blocked, we move. If it's off the map, we're done. Like that part seems right. So how do we test if we've hit a loop? Is our current position and our current direction the same as our initial start direction? Start and direction. So my thinking behind that is it's probably easier to look at one of these. Like this one is the tricky one, right? Because you're like, you go up, over, down, over, up, over, down, over, and now you're back up. Like if when I get to this position right here and I'm at that position and I'm facing up, I know I've got a cycle. So I should find this position right here. Oh, but does it? Okay, so the case it doesn't handle is if there's a box that's off the map that I'm not normally hitting. Is that right? Yeah, so like if placing a block here sends me way out somewhere into the map and that lands me into a cycle, that would be one as well, right? And so I'm not doing that case either, right? Hmm. So do I need to track all the scenes here? And if I see one that I've seen before, then I'm done? It feels like that's probably it. So we'll say let mute scene equal hash set new. And then here we'll do scene dot insert current position, current direction. And then here we'll say there like that. Okay, that went a lot faster. Is this the right answer? So that might have actually been it. Is I was just, excuse me, somewhere in here I probably can't find it. There's a place where like if you place an obstacle, it sends you in a new direction that you haven't been before that triggers it. Let's just try and solve it though, see if it. Oh, still not right. Okay, we'll keep working on it. I feel like that gets us closer though. It said our answer was too high. If we're ever off the map, it's definitely none. Oh, if we. No. If we change directions or change position, we want to insert and then loop again. It actually solves really fast without the parallel iterator. So I think I'm not sure we need it. We'll get rid of this stuff for now. It says it's too high. So there's some case where we found a loop. We can clean this up a little bit more later because we may want to do that differently. But we say 4-point direction in directions. So we're going to go each of the directions we've seen. And no hints yet. Let me see if I can get through this. Why would I find too many? 4-point directions in directions. Count directions, iter, filter map. So for each of the directions, I'm going to test going to call the find loop and count. This feels okay. Is there some special case that I'm missing? I mean, surely this hasn't changed, right? It's still 6. 33. That's not right because it was 6, right? Okay, so I actually have broken even the test input. Oh, I should only count this once? No. I mean, I think I should. No, if it's going multiple directions, I can count each one, right? Like the case I'm thinking about is, if this one has 2, so I should ask myself, if I put it here, does it solve it? And if I put it here, does it solve it? Oh, do you know what? Is it the case where, like right here? So like right here, do you see how there's like 3 different ones? From right here, I could potentially hit it. From here, I could potentially hit it. And from here, I could potentially hit it. But the obstacle would only be placed once. So I do kind of want to find a unique count of obstacles. Nope. I want to do... like that. I mean, I can fix this up in a little bit, but is some... And I want to do like a borrow this. Well, that gets it down further. I do think that is a problem, right? Is like you only want a unique list of obstacles. Do I consider if scene contains current position, current direction, we return true. Is there a case? I don't think there is. I'm trying to think of like what's going through my mind is there a weird case where being in the same place twice would not put you in a loop? And I don't think that's the case, right? Like if I'm ever going the same way and direction a second time, surely I found a loop, right? Like what would be the case where I haven't found a loop? What was my old code where it actually worked on the test input but not the input? What was I doing? Oh, I just put it in here, right? I just said find loop right here. Or I just said it I just said if my current position and direction is equal to my starting current and direction, it did it, right? Like if I get rid of these things, the one that worked was if we said if like that, right? But it only works for the test input. Yeah. But the case this one doesn't handle is if it sends me into a loop. Like the obstacle causes me to go to a place where a loop exists. Was the place I was thinking that this one doesn't solve. So could I change? Like what happens if I just add this stuff here? I don't think it's the test input. I think it's that it's well, the test input doesn't have all the cases, right? And I think that's what's going wrong. So this one seems to be returning. Oh, oh, uh, no. It's empty first. The number would be much higher. I thought it was, ooh, but maybe it was 6071. Yeah. Was that it? I just put that in the wrong place. Yeah, I put it in the wrong place. Huh. So what I was doing is I was checking to see if I had seen the item right here. But like that actually returns true for like all the cases, right? Presumably. So does that actually help me solve it with the input? It's not as fast as it should be, but it is a smaller number. It's still too high. Ah! So it's still finding too many? Oh. I should be returning the point. I should be returning point dot next direction. This is what I should be doing. This is going to be uglier, but we can fix it later. I need to do this borrow, I bet. Yeah. $21.72. I may have done this too fast. Still too high. Like my thinking is like the obstacle is not actually at here, which is what I'm passing it. The obstacle is in the next direction, right? But I mean that does lower it. Map position insert start next direction. I mean this feels like it's okay. So it definitely works on the test still, right? Yeah. So what other cases am I missing? So what happens here is I've now added a block in my map. And so I say, look for the next position. The very first time, it should always say, oh, it's one of these. So I'm going to turn right. And then I'm going to add that turn right into my thing. Or no, it's not going to be there. Now I'm going to add it. Now the next one I presumably should be able to move. So I move. And I go down a path. Eventually hitting another block. But in all of these, I'm adding the scene contains. Move. Turn. Current position, current direction. Okay, let's just look at it again. The idea is that for like each of these points, maybe it's easier to look at one of these. All of these positions right here, and I mean all the other ones, I'm going to look and see if I'm going this direction, can I add an obstacle in that direction? And does that cause a loop? And what would make this cause a loop? Oh. See, like this one. So notice. Oh, no, no, no. I think I'm wrong. I was thinking, like, do I pick up some of these? But that might be a weird case, is if like there's like inner loops and outer loops or something like that. I think the detector should still find it. But like the case that I was worried about is as I'm moving, do I ever see one of these again? But I don't until I get back to here, right? Presumably. So the idea is maybe I'm moving around and eventually I get in there. I get into the loop. And the way I know I'm in the loop is I've come back to right here. I've at the first time I've seen a new one is when I hit here. Now again, that always isn't always the case, because like I could imagine adding an obstacle where it sends me into a loop, right? So like the idea behind that one would be let's say the X, there's a hash right here, right? So I'm going down like this and I hit here and now I go up and my loop is actually right here now, right? My loop is up here. But I would eventually hit this one and this one. Do I just have to do like cycle detection? Like we've had days before where we do cycle detection. Like do I go until I've seen 2 loops? And if I've seen or so if I've seen this twice, then I have a cycle. Hmm. Let's look at the Wikipedia. This may be sending me down the wrong path. Um, I think this is the one I've used before, the tortoise and hare one, right? So the way that this one cycle detection works is the idea is you have one that's always moving like twice as fast. It's like calling the move function twice for each time this one calls it once. And eventually you land at the same they will land on the same values, and that says, oh, that is a cycle. So the idea in my code would be, can to do the cycle detection is I would just keep adding values to a vector of like all my positions where I've gone, and then run a cycle detection. or I could just keep appending values until I hit the tortoise and the hare hit a point where they've done the cycle detection. Man. Like what makes it so curious is like why is there not a cycle is because or why does that work over this is because it feels like I'm doing the same thing, but I must be missing some additional case. Am I like misreading the problem too? Let me just make sure. It doesn't really matter what you choose to use as an optical as long as you and the historians put it in the position with the guard. The important thing is having enough options you can find one that minimizes time paradoxes. In this example, there are 6 different positions. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Fortunately, you're pretty sure that adding a new single obstruction. They'd like to place a new obstruction in such a way that the guard will get stuck in a loop. Well, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. Yeah, it has to be the case that it's on a place where he's gone, right? So you look here, this one is a valid one because it would, like it's this line right here. He's going down here and then he's going over here. You put one right here. So it is, you'd only ever put it in places where the guard would go. So I do feel I'm right about that. Like my thinking is like, oh, is there something else to this that I'm missing? Diagram. The new obstruction can't be placed at the guard's starting position. Okay, genuine question. What points are you testing? What are the directions you are iterating? So good question. So like I can double check it to verify, but like as I'm doing part 1, I'm inserting the current position and the direction. Oh, but that might be wrong. That's generally the so like my thinking was, and maybe I'm doing this wrong. I have a defect in how I'm doing that. But like the idea is like in this graph right here, he starts like right here, right? And he goes up. So I'm testing all of these ones, all of these ones, all of these ones, all of these ones. Da, 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 da. Right here is one where it crosses. So I need to test both ways. I need to say, what if I put a block here or put a block here when I'm going this, when I'm using this one? If I put a block here or a block here, should do either of those to cause this one to go that way? So is this the way I'm doing it? Is it really a difference of like doing this? I don't think that's the right answer. 2172. That makes it higher. But you do make an interesting point is like, or the question does, like, what are these, what directions am I choosing? Where do I want to insert the directions is the question I need to be asking. It's actually up here, right? Because I want to be able to do the first one too. I mean, that gives me the same answer, which I'm sure is not right, right? I think the last time I tried to solve it, it said it was too high. Yeah. Because the initial position and direction is also one that I want to add. Directions entry, current position or default. Push direction. Yeah, so the idea, and maybe I'm wrong, but this feels right, is like any place I've been in part 1 is a place I could put an obstacle. So like up here, any of the X's I could put, I could potentially put an obstacle in any of these places to change how the guard would move. But if I ever get like a duplicate movement, which was like this one, I could test both these places, right? I mean, this isn't a great example because I'm going to test around here anyway. But like the cases I'm thinking about is like, say this one has 2 ways, and I don't know why it would, but you might want to try an obstacle here if I'm coming this way. Because like say this one actually sends you off the map. You could put one here that could potentially make you go up and, you know, maybe form a cycle that way. Hmm. Yeah, because even the case where we break down here, that's like where we've fallen off the map. Oh. Surely I'm checking down here that it doesn't take me off the map, right? Yeah, if I would place, if the direction would place me off the map, I don't go that direction, or I don't even try that iteration, right? Like if I was to place an obstacle off the map, that doesn't help me. Okay, maybe we start thinking about. Can we change the test input to be kind of funky? Oh, let's see. This box case, I don't know if this is actually one of them, but there are cases where it doesn't solve. Let me find one of those boxes again. Where was that? Where was one of them? Right here. So these three right here. If I'm testing right here, like say for some reason it went like this, and then back out, right? So like something caused it to go back out like this. I can't place an obstacle right here because it would just, this would find a cycle, but it would never get there anymore, right? Shoot, I have to start from the beginning, huh? I just place a block in those places and then I start from the beginning. Yeah, I'm almost sure that's it. So the start is a point, and then the obstacle is a point as well. And just what I do is I say if I get the obstacle point and it's some dot, I want to insert obstacle with a hash now. So I want to replace it with a hash. Copy it. And then the current direction is north. So I'm going to start from the very beginning and see if I ever get put in that position. So what changes up here? The start is always the original position, and the obstacle is at point dot next direction, like that. Does that still work? Okay. $21.65. That is the lowest one I've gotten. I think my lowest before was... Ah, we got it. Whew. That was a long solve, 2.5 hours. I mean, you know, a lot of debugging is what it is. So what was I missing? Like what was the thing that I was missing? I feel like what, or maybe just overall what went good. I kind of feel like it's clearly like a graphing thing, and like the part, so I think treating it as a graph was good. The part that I failed at that I think was where I missed it was finding the cycle detection, which you had actually mentioned Future Highway, right? Is like, I think the issue is the cycle detection. And it was the reason it was wrong was because it was why was it wrong? It wasn't. It's because it was just looking. Have I been there? Have I been in that place before? Right. And it doesn't account for all of like the crazy cases. Uh, where you say like this box, right, is like if I put one here, it doesn't account for that. And so I started, right, like if I just started here and then put this here, that doesn't help. And so what would that, how would you do it without starting from the original position? Like in this case, you'd have to just be smart enough to say, oh, this is, I can't get out of this one. And so I have to, so this one can't be one. I mean, you could do something more complicated than that, but it would be faster. Oh, so can we make this faster? Is there a time function? Oh, I can do a timer here. Okay. So 2 seconds. For part two. Yeah, what would make this faster? I could still try Rayon. So how would that look? Let obstacles equal directions dot values dot, oh no, I want all of them, dot iter dot, I tried to do this before, huh? The iter doesn't work. I got to do a par iter dot map point directions, and then I turn each of those into a hash set, and then I turn this into a, actually this can just be an array or a vec. So I collect them all, and then I collect these into a hash set. And then I can, like this. Oh, now I need to add this, but spell correctly. Okay, what doesn't it like? Oh, I've used it up here. Okay, does that make it any faster? Yeah, it does, but it's just because I've, oh, but it doesn't give me the right answer. That's fine. Let me do this. Nope. It doesn't give me the right answer. Seriously. It's probably because I'm doing something right here, right? It's not a point. That's crazy that it doesn't work. For each of the directions, do a par iter, do a flat map, directions iter filter map. So for each of the directions, I'm going to filter on does find loop succeed. Is it this? Maps an option T to an option U by applying the function to a contain value if some, or returns none if none. Oh, it's not just the point. No, it is the it's not the point. It is the dot next direction. Okay, this looks really ugly, but that was the right answer, right? 2165. Okay. Okay, that's what I was missing. I was just not putting the obstacles correct. Yep, there you go. Perfect future highway. Yeah, that was it. So, I mean, if I like turn on the fan of my CPU, I can get it down to 280 milliseconds, which is like 8 times improvement. But it's still not super optimized. To be honest though, 1 to 2 seconds is okay. It's not. I'm sure we'll go look shortly, but there's definitely there's definitely been problems that took longer to solve and were still considered like the correct way to solve it. So my guess is that even without using the parallel iterator, it's okay. I don't know what button I pressed there that got me that thing. All these things I learn about Windows. Can we see it spin up? It happens fast enough that we probably can't see it on this graph. It may not even end up using all the processors. How do I change this back? Change graph to overall utilization. Okay, so it's like right here. I mean, you do see a quick jump, but it clearly is not using all of the CPUs. So, I mean, I don't know that that helps you. Okay, let's go look at some of the solutions or what people are saying. It's been a few hours, so here we go. Part 2 took me 30 minutes. 30 minutes to code. Huh. Okay, that's definitely where I was heading. I mean, I think I don't know. Is it brute force? We'll find out. Took me 30 minutes to read. We are not the same. And I was skimming out. I put a block on every possible square and checked it, and it took 75 seconds on my machine. You can shave off time if you only put blocks on squares from part 1. Yeah, so this is what I did, right? And it only took a little bit of time. So this guy's saying if you try literally every square and then run it from the beginning, that helps you. Yeah. Which is essentially what I did. Oh, this guy's using Godot. Or is it Godot? I guess I haven't watched videos where people have said it, so I don't know how you say it correctly. I have played with it like really briefly. Nothing in this, but okay. Here we are. I think we are in this camp, right? Next time I should wear my tie. Maybe the guard doesn't actually care about us being in the lab. Yeah. Okay. Yeah, you don't want to look. I love AOC. Me too. Okay. Yeah, this has been a problem ever since she became a senator or a congresswoman. Oh, is this Pokemon? I do remember these actually though from the Zelda games. I used to play Zelda. I mean, I still do when new ones come out, but like, I remember these little puzzles. This little mover is gonna. Okay, here's where I was when trying it. Uh, but it ended up being that it was just that I was missing some stuff, and so I was in some infinite loops. Right? It's day 6. Is my input just big? Okay. Yeah, this one took a while. I told my wife I was gonna set up the Christmas tree tonight, so I still got to do that. Um. Okay, yeah. Here's what mine looked like when I was brute forcing it. These people must be struggling with as opposed to just trying obstacles on the path, they just tried literally every single one and every single. Okay, so maybe that. I bet you that still gets you to the solution. It's just you have to try substantially more possibilities, right? Because I think, let's see. Yeah, so can I go um right here? I can do this over this, and it's directions dot values dot over map dot positions dot lane. Yeah, so I'm only trying 6,300 and they're trying 17,000. That's a good point. Like if they're using Python, it's not nearly as efficient. Yeah, that's fair. But the only time my CPU was doing this when I was stuck in an infinite loop, right? So anyway, there you go. Okay. Lots of people using lots of CPUs. Ooh, for some reason that makes me dizzy. Okay, let's look at some actual solutions and then we'll be done with this day because it was a long day. Um, Simulate the game and keep track of visited points to avoid redundant counting. For each point in the path of part 1, put an obstacle, then simulate and check whether a cycle occurs or not. Here, too, you need to keep track of points where the obstacle has already been placed before to avoid extra counting. Check for cycles. Then I got it down to 20 seconds by using a dictionary. Yeah, that's what I did. I just used a dictionary. A linear operation to check for cycles. Was he maybe he was using some kind of cycle detection like this Floyd's? These cycle detections can actually be useful. They probably just weren't necessary. Okay, let's look at his Python code really quick. Check loop. Yeah, he's actually just moving the guard and then checking to see if he's seen it before in this thing, is what it looks like he's doing. Count plus equals 1. Okay. Yeah, I mean this is basically the Python equivalent of mine. So the question is like, is this more readable than mine? Potentially, because mine looks like trash right now, right? I definitely need to clean it up a little bit. I don't like returning an option here. I probably ought to try and fix that. Okay, but let's look at some others. This guy got on the global leaderboard. Turns out I was mistyping my answer. I've seen too much bad Java code. I closed that just by default. Yeah, he's using a grid. Testing for that. Loops. This one may be faster because it looks like he's kind of... No, this is part 1. And then he loops through the visited... Okay, so he did do something similar to mine. Is like... He goes through all of his visited list and sets this and then tests if that would create... and then calls this loops function, which I presume checks to see if that would cause a loop. And yeah, he does. He just starts over again. Okay. So that one does look similar. I did slow and fast. Didn't occur to me I could do the hash set to check direction or position. Okay. Yeah, I think the hash set is probably the way that most people did it if they got it solved relative. Raku, Raku. I don't even know what that is. Oh, this feels very like Python or Perly. I don't want to try and grok that. Java. Let's look for... Okay, here's a Rust one. Part 1 solved it pretty quickly. I mean, part 1's not hard, right? You're literally just moving the guy around. Part 2. What does he say? Yeah, I'm in the same boat as this one right here. Bad assumptions that resulted in overcounting. And this happens a lot too, right? Is like you'll get a test case that doesn't... that you'll pass, but then like the actual input doesn't pass, and it's just because you're missing like specialized cases, right? I was adding obstacles to... but I forgot to check the path hadn't already been passed through the position I was checking. Yeah, like this is the thing that I ran into, right? Is like if you put one in a spot, it can't be in the way of like a path that got you there, because then you'd never actually get in your cycle, right? If the elves can time travel, sure they could just add new obstacles once the guard passed that position. Yeah, that's true. Thanks, time machines. We could try FX hash. See if it's any faster. Let's see. There's a really easy way to just add it, right? You just tell it that you want it to use... You want your hash set to use FX hasher, right? Oh, it's not this part right here. It's down here. fx hash set default, like that. I mean, it does feel like it adds a little bit, but not a lot. Like maybe we're in like the 2 to 3% range. Sometimes that can help a lot, though, right? That can be like, yeah, it shaved like 15 milliseconds off of, so like if you think about, well, maybe 20. So it went from 270 to 250, kind of in that order of change. Racket. Why does the racket look like Lisp? My first language. I mean, it has some weird things in here, but it looks like it is Lisp-like. Okay. Okay. Hey. Oh, I should turn this off, by the way, so you guys don't have to see my wife get mad at Walgreens. Oh, let's look for Rust ones. How is this one debuggable? Like the one case, it doesn't handle the one case where you put yourself. Oh, maybe it does. Okay, let's see what he does. It feels like he's knows what he's doing though. What are utils? Oh, this must be his advent to code thing, and so he has some helper functions. Calculate route with obstacles. Movements, hash map new, movements insert the current one, obstacles new, in route true while in route. Tango, calculate movement with obstacle. Is there a U there? Am I spelling obstacle wrong? He might be a non-English speaker, or like English as a second language, because his English seems fine here. Anyway, I don't know why he calls it, or I could just be obtuse. That's possible, and not sure why it's spelled that way. Make movement key. Insert movement. Make an obstacle. Oh, he has some like debug. It feels like he's doing the same thing as me though. Just like putting obstacles on the path and then seeing, let's see here. Yeah, you can see here. So this up here he calls the, so as he's going through the path again, and then he calls this, where is it? Check obstacles or whatever. Down here, where he like kind of simulates pushing through it and seeing if it causes an issue. This one probably helps with the debugging. That's interesting. kind of want to try it. See if I get 19 too. Yeah. Okay. I mean, it does work, but it is an interesting, like, what is this one doing? It's probably those places that I was talking about where, like, you can't put it in a place where you'd want to go back there through the loop, I guess is what it is. I spent 9 hours. Okay. I mean, it took us 2, which is probably higher than my average day 6. Uh, Stay with the mechanical path. Process. The guard doesn't turn right and move. Last I checked, he can't teleport. When checking for loops, you might enter an infinite loop. I didn't have loop detection and just let it keep going. I knew something was up, but I still hadn't calculated. Can't put a blockage. I guess I don't know exactly what these are, but I mean, clearly you run into problems, right? Yeah, it's this part, the block where you've already walked type thing. I wonder if you could fix that. Like, the idea is you can maybe, because you add the obstacle, you hit the path. Waited an hour. Oh, he let it go for an hour. Okay. Sorry, that is a good point. I mean, I don't remember the exact number, but the maker of it has talked about it before that, like, most of it can be solved in like seconds and not minutes is like the goal, right? So if you're, I think I've had solutions before that took 7-10 seconds, and they've kind of said those ones are kind of okay because just depending on what hardware you're running it on and what programming language. But it shouldn't take an hour. That's a good point. I knew something was up when it still hadn't calculated after an hour. Okay, good. Yeah, that's a why wait an hour? I guess you could be debugging it while it's running. I've done that before just to see if it and I've actually seen, I don't know if anyone's ever watched people do the that go for the leaderboards that are like way better than me, right? I'm just mostly interested in, like, can I find algorithmic rhythmic solutions to these problems? But like the people who do it fast and for speed, they'll often let it run and try and then optimize it while it's running, so that if it just so happens that the unoptimized version only took 30 seconds to a minute, but you can still solve it, that solved the problem for you, they'll do that. And so maybe he was doing that, but yeah, waiting an hour is pretty long. My solution takes 20 to 30 minutes. Okay, I do understand Lisp, so I can try and grok this. Um, guard, different guard figure, coordinate equal directions. Find guard. Guard on map P, mark map. Get guard path. 5 a.m. What is that? It's not like day 6 or anything. This must be like a package that I'm just not familiar with. He does have some AOE tools. Okay, let's look at the part 2. I mean, it looks like he only does do it on the current path. Let's see what possible barrier does. Where was that? Oh, did I lose my... Did I close it? Or maybe GitHub just doesn't do this for lists. But sometimes GitHub will know the language and can find the functions and where they start and where they don't. So we're looking for barrier, possible barrier. I guess I could be the search. Oh, that's the name of the list. Do list, possible barrier, remove it. Map, copy input guard, copy guard, initial guard. Mark map, possible barrier 0. If the guard is when check if guard loops on map. I mean, I don't think he's doing it any different than I am. So is it just, it's not unoptimized? Get guard path. Check if guard loops on map. I mean, part of the problem with lists is that it looks like there's a lot of copies, and so maybe that's what's slowing it down. Usually the compiler can help you figure those out, though. I mean, sometimes it can't. Like with Haskell, if you don't do it the right way, you can... I understand lists better than Haskell, but sometimes you can get into a point where it just has to do copies, and so that makes it slower. But 20 to 30 minutes is really slow, so there must be something I'm missing. Oh, he's using a list. Okay. That's probably it. I didn't even see that. Yeah. I mean, that would do it. Is if, especially if the list gets really long. A lot of functional have gotten the slowdown due to inefficient lists. Yeah. I mean, they aren't necessary. They're just linked list is the issue. So if you're doing like searching and indexing, you really should just use the tools hash set is what it is. Okay. I don't see any. It'd be nice to like not look through the memes. Did someone do it different? Rows and column. What if I told you it's not only possible to solve the problem in ONM, but you can find the answer for every starting point and direction at any given moment? The guard must be in one of 4 NM states. Correct. For any state, the guard has exactly one new state to move. Which state depends on the configuration of the grid and the placement of the block. Yes, that's okay. You see states, you see transitions, you think graphs. Model this as a graph consisting of 4 NM nodes corresponding to each state. Add directed edges to model the state transitions according to the following rules. Okay, so these are the you don't turn. These are you do turns. So the edges these are the edges of these. So you basically have two. So this is using a graph theory. He's saying use the graph idea where you probably load these into the nodes are one hash and the edges are another. I mean, I guess you can add the nodes and edges however you want, but okay. For the construction, two incoming edges and exactly one outgoing edge. I have to think about that for a second. For the construction, it's easy to prove that each node has at most two incoming edges and exactly one outgoing edge. If you start at any node and move along the directed edges, you will either end up in a simple cycle or at a dead end whose next step takes you outside the grid. In other words, the graph consists of some cycles or rings and bunch of tails. The tails either feed into one of the cycles or they exist on their own. If no hash additions are to be made, it's easy to determine if the guard will end up in a loop. Checking if the starting state ends in a cycle. Now consider if you convert a dot to some cell. This is equivalent to deleting all the nodes x, y, star from all the edges. Follow this by redirecting the incoming edges. If we can officially figure out whether a given node ends with a cycle after this shift in constant time. Okay, I'm having a problem grokking this part. This makes sense, right? Is like if you've built this like complete graph, like wherever you put this, wherever you put it, put your obstacle. Like you can put your obstacle in any of the IJDs. Or sorry, it's actually you put it in any of the IJ stars and you put it there, and then you need to delete all the incoming from those and change the adjacent ones to be to change the outgoing of the adjacent ones. We can pre-calculate for each component if it ends in a cycle and not when it ends. Jurassic Park scientist meme. It feels risky. Is it the didn't ask if we should, but asked, or we forgot to ask if we should type thing? Oh, okay. Okay, this is interesting. So he got the 4NM to do the cycle detection, which is also a way, right? Is you can just say, I don't think that this way is as efficient, right? Because you're always taking 4NM steps. I guess it's only on the cases where a cycle is found. So of like for example, the 6,000 that I tested, somewhere around 2,000 of them should be obstacles, and in each of those, you'd now try 4NM times as opposed to just me doing the hash set and finding the cycle, right? We're not finding it. Okay, it feels like this could work. I mean, this is definitely more complicated, but you can see what he's doing is basically saying, I'm not just gonna make a graph of like the nodes and have the edges be like the north, south, east, west. He's making a graph where all the nodes are all the, directions and or sorry, all of the positions and directions. So each position has 4 directions, and then you join them with edges like this, and then you can do like this edge elimination here, and then you can do normal graph cycle detection in that graph where you can say, uh starting from my point, now I move around, and if I ever hit that point again, I know I'm in a cycle. Is this faster though? I mean, it is constant time. What is the time complexity of mine? Um okay, and then after this I got to be done. I've spent way too much time thinking about this. Forever is also constant. Yeah, there you go. What is my time here? For each n, I guess mine's variable. I think mine is, I mean, when you say constant time, I don't think mine is like, I don't think these solutions are like exponential in any way. I mean, mine is n times m for a different m. Like these contains and inserts are O1. Or like, I mean, technically they're n log n. This is O1. No. N log n O1. I mean, I think mine's still logarithmic. It's probably logarithmic. So, and I'm n. I guess I am n squared log n. Something like that is what I. If I had to guess what mine was, it's something along those lines. It's actually m times n log n is like what mine is, I think, which is still fairly good. I mean, you can't get, it's not constant. You're right, but constant is forever. And the point, like I think you're making, is like, it's quite possible that the number of comparisons I make are smaller than n times m. Man, I don't want to keep digging into this too much, but I could potentially track how many times I was in it. I was in this loop. Well, we have an idea of how far I was in it. Let's go back to the input. So I test it 6,300 times. So that's my n. And the path is 5531. And what is the size of the graph? I mean, his might actually be smaller. It's 130 by... I don't know, 100 times 100. It's somewhere on the order of 10,000. But he has had to build up the graph as well. Yeah, my guess is like this complexity may not net you anything because you've actually had to build out all these nodes that I have not built out. So it's also possible that his is more CPU, like his is O and M. It's 4 NM. Oh, so his is like 40,000 and mine's like 6. I could do like a rough. I think mine's 1 order of magnitude higher. 6,000. Yeah, so his is 40,000 and mine's on the order of like 300,000. So mine's 1 order of magnitude bigger, but probably like 10 orders of magnitude smaller memory wise. So who knows what that does for your casting time. I would be interested in him implementing it though. Okay, I feel like I've talked about this enough. So I will try though for the weekend. We'll keep trying to stream live. To when will I do it tomorrow? That's a great question. Probably tomorrow evening again. I think I have family stuff all morning and day. But I'd love to see your solutions. So I'll post a gist of this with the video. And then I'd love to see what anyone who watched it, how they solved it. And I'll post mine. Maybe I'll try and do some cleanup of this if I have time. On the weekends, I don't usually have a ton of time. Like when I'm at work, if I'm in a boring meeting or whatever, sometimes I'll try and refactor it a little bit. But so we'll see. This one seemed pretty efficient. So there we go. There is day 6 in the bag. I'll see you guys tomorrow for day 7. Bye, everybody.